In the previous video, we went through a collection of text. We extracted the words and we counted the number of times each word occurred. This is often used in information retrieval as part of the analysis of a document. We put the words into a vector. The vector was indexed by the word, and the value at each element of the vector was the count of the number of times the word occurred in the document. And the file, which is in the other video, the most recent video, looks like this. When we get down to the end here, we write out the word and the value in the vector, up arrow dict, that contains the count of the word, and we used order and that sort of thing. What if we wanted to have a sorted list? To sort the list according to the number of times each word occurred, from, say, lowest to highest, from the least number of times a word occurred to the most number of times. Now, we use this in information retrieval in order to locate words that are very broad frequency, that are probably not good indexing terms, like the word the word are, have. These are poor indexing terms. They tell us nothing, and they're in documents in a very large count. So what would I do? Well, this is a little bit peculiar to my system, but I think most versions of Mumps have something similar, so you ought to be able to do it there. First of all, we're going to open a new file. Since Unit 1's already available, I'll open 1. It's been closed, so it's safe. Don't open an already existing file. And I'm going to create a file called temp.temp. And it's a new file since we're creating it. And I should check to see if the open succeeded. If not, $test, right, some error message, something like that. Whoops, quote, comma, exclamation point, and halt. Again, it's usually good to check, although unlikely anything would happen. Okay, so I've opened a file. Now, instead of writing to the screen, which we were doing, we will now switch to unit number 1. So all of this output is now going to a file. It's not going to the screen, it's going to the file. At the end of the loop, I'll close unit number 1. I'll switch back to unit number 5. And now I want to sort it. Now, in my version of Mumps, there's a command called shell, which allows you to execute a command in the underlying operating system. It creates an operating system shell, and you can execute commands in it. Well, I want to do sort, which is a standard Linux. I left something out up above, I just noticed. A standard Linux program, it's part of your system, which sorts things. And the input will be temp.temp, and the output will be, let's call it temp.out. What I forgot here is I want to rearrange these things. I want to put the count first. Okay, that's the count. It's in dict sub w. And I want to put the word second. Okay, and let's clean this up. So the output is going to be different. It's going to be the count first, followed by one blank, followed by the word on each line of the output. Because I want to sort it by the number, I want the number to be first. I could sort it if the number was second, but the sort command gets messy. You have to talk about fields. In the sort command, again, this is a standard Linux. It's not really a command, it's a program, but you type it in as though it were a command. The sort command, if you don't tell it what field to sort on, it sorts on the first field. If you say -n, you're telling it to interpret the first field as a number and sort it accordingly. Okay, so that should sort it, and it will create an output file called temp.out. Let's find out if it works. We may have some surprises too. Let's see if I can find the previous execution of the thing here. Well, read.mumps. Thought I had an input file attached, but I don't. Okay, and it's running, and you see all the echoing of the input lines. And did it do it? ls temp star. Yes, I've got 2 of them. ls-lh, see the full size. And they're both the same size. They should be. One's just a sorted version of the other. Let's look at temp.out. That should be the sorted version. UT. Yes, well, there you go. There's the numbers, and there's the words, and you see the count, and it's ascending, Now, within a given count, it'll be alphabetic. So at 140, O comes before T. Let's go back a bit. 95, you see it's A, H, L. You know, it's in alphabetic in a given number. It's just because of the way the thing was originally written. But there's a little problem at the front here. This is the beginning of the file. We get some numbers in the file. We should probably get rid of numbers, but that's not the point. They're treated like words. They're, for all intents and purposes, words. They just contain digits. What's the problem? Well, the problem is 5. It seems very unlikely that there are no words in this file that only occur once. That the least frequently occurring quote-unquote word is 1156, and it occurs 5 times. That's unreasonable. So what went wrong? Something went wrong. Here's the program. You can see where we read the line in. We remove blanks. We converted to lowercase. We got rid of punctuation. We extracted the words on the line. We checked to see if the element of the vector for a given word exists. If it does exist, we simply increment. If it didn't exist, we create it and give it a value of 1. So how did it go wrong? Why is there the minimum value 5? Well, very simply, every time we run this program, we're using the same database. The old version of up arrow dict is still there, and oddly, of course, it has the same words. So every time I've run it, and I've run it 5 times, the minimum, the word with the lowest count, is incremented again. So what I failed to do is I failed to delete any previous version of the database, which would be kill up arrow dict. Okay, get rid of it. Otherwise, you're using old data. You're incrementing old data. It's very easy to do in Mumps because we tend to think in normal programming languages that when we start a program, all the variables are new, but they're not in Mumps, not global arrays. They're old if they exist. All right, let's run it again. There it goes. And now let's look at 1, count of 1. The number or word 1156 occurs once, which makes sense. Now the counts you see are different. It's quite a few words, as it turns out, that only occur once. I'm probably going too fast for the capture to work, but and we get down to the very end here, and you can see some of the words which are useless. Since this is a short story and there's a lot of narrative, the word said is there 187 times. The word that is there 173 times. Gabriel is there quite a bit. That's one of the characters. That's unusual to see a proper name like that occurring that frequently, but it's done frequently. The word is used frequently in the story. With, aunt, there's a whole group of aunts there. So you can see these are the high-frequency words, and for the most part, they're usually not good words for indexing purposes. On the other hand, words that only occur once are not very good either. So if we were, this is a very small sample size, but if we were doing in a large sample size, the very high-frequency words would be the usual words like and of and for and but and so forth like that, and they're not indexing terms. And likewise, the very infrequent words are not indexing terms. Sometimes they're one-offs, they're spelling errors, they're numbers, things like that. Okay, so